What if Earth's axis was tilted by 90 degrees? Imagine a world where the fundamental tilt of our planet is not the familiar 23.5 degrees, but a dramatic 90 degrees. The implications are colossal, altering every aspect of Earth as we know it, from the rise and fall of the sun to patterns of weather, the rhythms of ecology, and even the history of life itself. To grasp what life on such a world might be like, let's explore the planetary mechanics, the transformation of our climate, the reshaping of landscapes, the impact on oceans, and finally, how life, both past and future, would have to adapt to this profoundly different Earth. To begin, consider our planet's current position in space. Earth is tilted at an angle of about 23.5 degrees relative to its orbit around the Sun. This modest tilt is the reason we experience seasons. It leads to the northern and southern hemispheres alternately leaning towards and away from the Sun throughout our annual journey, causing the classic cycle of warm and cold periods. It also leads to days and nights of varying lengths, long summer days, short winter ones, and the familiar pattern of sunrise and sunset across the globe. What then if that angle were quadrupled to a staggering 90 degrees? This means that over the course of a year, each pole would directly face the sun for months at a time and then turn away, plunging into prolonged darkness for the rest of the year. The consequences would sweep across every sphere of life, rewriting the script of Earth's environmental story. Let us first visualize the planet's position and its new dance with the sun. Instead of turning with a gently angled axis, Earth would spin on its side. Picture a spinning top that has been knocked completely sideways, its axis laid almost parallel to the plane of its orbit. At some stages of the year, the North Pole would be pointed almost directly at the sun, bathing it in constant daylight, while the South Pole would be shrouded in unbroken night. Half a year later, the positions would switch. South Pole basking in light, North Pole in darkness. The equator, instead of experiencing relatively steady day and night all year, would now oscillate dramatically between sun and shadow, its inhabitants seeing the sun climb directly overhead for a short season, then dropping to graze the horizon or not rise at all. This extreme tilt would create seasons so powerful and elongated, they barely resemble what we experience now. Each pole would enjoy a day lasting 6 months, followed by a 6-month night. The temperature swings between these two periods would be astonishing. While the pole basked in sunlight for half the year, the energy pouring onto it would be relentless. With the sun continuously above the horizon, warming would be continuous. As soon as the sun set for its monumental half-year night, that same region would cool rapidly, losing heat into the darkness. At the equator, there would be a short burst of intense solar exposure as the sun passes overhead, but for the remainder of the year, the sun would hover near the horizon or disappear altogether. Day and night, as we know them, would vanish. Instead, each year is split into one half day and one half night at the poles. At the equator, there would be 48 hours of real sunrise and sunset during the entire year, with the remainder either in extended twilight or indirect sunlight. Cities sitting along the tropics today, places like Quito or Nairobi, would switch from being lands of eternal spring to places with wild light swings and temperature extremes. This supremely altered arrangement would also upend the very basics, our experience of time and navigation. Timekeeping, as based on regular day-night cycles, would lose its meaning. Human society, if it had evolved to this point, might base the calendar on the coming and going of the endless sun, or the arrival of night, instead of familiar days and weeks. Interwoven with these profound changes is the radical reshaping of our weather and climate. Earth's climate is intricate, affected not only by latitude and the angle of sunlight, but also by the tilt of the axis. A 90-degree tilt would see the poles transition from being icy wastelands to being the hottest places on the planet during summer, and back again to frozen darkness in winter. While bathed in sunlight, a pole might, paradoxically, become hotter than what our current tropics experience today. Since the sun would never set, the warming would be uninterrupted, accumulating without respite. During the endless day, ice at the poles would melt rapidly, Plants might even briefly colonize these zones, with bacteria and other forms of life darting through heated puddles. Yet, not long after, as the pole turned away from the sun, this influx of energy would come to an abrupt halt, and temperatures would plummet. What little warmth had accumulated would flee into space, ice would reform, and organisms would need to survive an unthinkably long polar night. Only the hardiest microbes, or perhaps nothing at all, would thrive. Meanwhile, the equatorial regions would oscillate between extremes. For a short season, the sun would shine down directly, giving a brief, intense summer. The rest of the time, however, the equator would be a perpetual zone of dusk or total darkness, receiving little to no sunlight. As a result, the equator, often lush in our current world, would become a marginal and perhaps frigid environment, unable to support dense forests or vibrant jungles. Think for a moment about the consequences for our familiar wind and precipitation patterns. Today, Earth's weather engine is powered by the difference in heating between the equator and the poles, driving warm air toward higher latitudes and pulling cool air toward the equator. These movements create prevailing winds, monsoons, and the currents that transport rain and maintain the rhythm of our seasons. On this reimagined Earth, this engine would sputter into chaos. With the poles substituted as hot zones for half the year, wind patterns would realign, chasing the path of the sun's energy as it slowly waltzed from one hemisphere to the other. During each pole's sunlit months, towering columns of warm air would rise, creating low-pressure systems and reorganizing global wind belts. Ocean currents, as we now know them, would be transformed, following the new temperature gradients from pole to pole, instead of from equator to pole. Rains would follow the sun's gaze, deluging the poles in their 6 months of sunlight, and then shifting away. The equator would largely dry and cool under a permanent shadow for most of the year, perhaps fostering deserts or even icy expanses. Overall, the seasonal climates most of us are accustomed to, with gently changing springs and falls, would be replaced by cycles of baking, unceasing summer, and brutal, endless winter, particularly in polar regions. With such profound temperature and light extremes, the ground itself would transform. The North and South Poles, currently buried under thick ice sheets, might melt entirely each year, unleashing torrents of meltwater. This water, with nowhere to go over the now warmed poles, might flow into the newly thawed soils, swelling rivers or creating broad summer lakes and marshes. As the 6 months night returns, this water would freeze again, perhaps trapping animals and plants as sudden bitter cold swept across the land. The cycle could also erode coastlines, as repeated thawing and freezing split rocks and soil with relentless force. Along the equator, permafrost might take hold most of the year, with only the briefest of summers to allow plant life to survive, much like the current tundras of far northern Siberia or Canada, but wrapped around the planet's waist. It is possible that the landscape would be especially harsh, with windswept barren plains and only the toughest life managing to eke out an existence. Our oceans, too, would change dramatically. Sea ice currently waxes and wanes around the poles, but with each pole alternately basking in continuous warmth and then plunging into darkness, the annual cycle would be wildly exaggerated. Massive melting in the sunlit season could raise global sea levels temporarily, only for prodigious amounts of ice to reform during the long polar winter. Coastal flooding and freeze-thaw cycles would devastate marine life and reshape coastlines, especially around what are now the world's temperate regions. Currents, likewise, would be reshaped to flow from whichever pole was currently in the sunlight towards the opposite, now dark and cold pole. Phytoplankton blooms, the foundation of marine food webs, would explode in the lit pole's oceans, while the darkened sea would become a biochemical desert, perhaps echoing some of the great biological booms and busts of Earth's deep history. Waves of productivity would chase the sun as life marched from hemisphere to hemisphere. Tracking the year's slow rotation, the biosphere would need to invent startling new strategies. Plants, for instance, cannot survive months of darkness, nor can most animals tolerate 6-month stretches of cold or heat. Only species capable of monumental hibernation or dormancy, or those that can migrate thousands of miles, would have a chance of thriving. Alternatively, life might cluster in the oceans, where water buffers the temperature extremes and persistent currents could ferry nutrients and warmth to more stable locales. What about humanity? If such a tilt occurred in our own recent history, our species' survival and civilization would be hugely challenged. Agriculture, the backbone of civilization, is based on predictable seasons and reasonably steady climates. In a world split between burning polar summers and frozen equatorial winters, consistent crop growth would be nearly impossible over vast regions. Nomadic lifestyles might dominate, as people move endlessly, chasing the sun and the brief growing seasons it may provide. Cities, if they existed, would need to contend with enormous migrations of water, ever-shifting coastlines, and dramatic swings from searing heat to Arctic cold. Architecture might focus on insulation and flexibility, with buildings designed to withstand both tropical sun and freezing night. Power generation would depend less on solar and more on stored or generated energy, perhaps from winds racing between the sunlit and darkened hemispheres, or enormous stores of thermal energy banked in massive tanks. Human society would also need new kinds of calendars, tracking not weeks and months, but the all-important arrival and departure of the half-year-long sun. Religion, culture, and myth would revolve around the epic drama of the sun's arrival and departure, the agony and joy of endless light and darkness. A rapid tilt of Earth's axis, which could only come about through a colossal collision or another cosmic event, would also spell disaster for present-day life. Tectonic forces might shift, volcanoes and earthquakes could be triggered by the new spin, and long stable ice sheets might collapse into the sea. Forced to adapt in mere years or decades to a new planetary order, countless species would struggle to cope, and mass extinctions would be almost certain. Viewing these changes on geological timescales, we might see some faint echoes in Earth's past. Our planet's axis has wobbled and shifted slightly through the ages, a phenomenon called axial precession, but never to such extremes. However, some studies of ancient Mars and Venus suggest that planetary axes can shift dramatically, whether due to interactions with other planets or giant impacts. Given enough time, life could once again adapt, especially in the oceans where the extreme cycles are less pronounced. Evolution would favor creatures with long lifespans and rapid reproduction, those able to hibernate or migrate on vast scales. Plants might evolve seeds and spores to withstand endless cold, unleashing blooms during the wild half-year summers. Trees, if they existed, would need to grow and die in relentless cycles, perhaps dropping leaves in anticipation of months of darkness. If humanity had time to adjust, hundreds or thousands of years rather than mere decades, perhaps we would see truly global cultures, endlessly shifting, structured around the shifting light, with technology and migration as crucial as language and family. Our descendants, adapted to this dizzying world, might look upon our climate and our simple two-season agriculture as strange and primitive, a relic of an easy, forgotten time. As we contemplate this radical rearrangement of our planet, it serves as a reminder of the delicate balances that permit life as we know it. Our comfortable seasonal routine is an unlikely accident of celestial mechanics, not a guarantee. A modest tilt, so easy to ignore, underpins the warmth of summer afternoons, the sparkle of snow in winter, and the regular rise and fall of the sun. Everything we know, and everything we are, could be overturned by a mere nudge in the tilt of our world. In this exercise of imagination, we see both the fragility and the resilience of life. The interconnectedness of atmosphere, oceans, land, and living things means that a single change echoes through every layer of the planet. Yet, even in the face of unimaginable change, life might find a way. Seeking out the light, bracing against the cold, adapting and evolving, as it has for billions of years. Through this lens, our world's gentle tilt is not just an astronomical curiosity, but the quiet foundation for all the richness and complexity of earthly existence.